Good morning, all students. Welcome back to the next session of Bernoulli's equation, that is fluid dynamics of module number 3. Here in this session, we shall solve some problems on fluid dynamics using Bernoulli's equation. The first problem is a pipe through which the water is flowing is having diameters 20 centimeter and 10 centimeter at the cross sections 1 and 2 respectively. The velocity of water at section 1 is 4 meter per second. Find the velocity head at section 1 and section 2 and also to determine the rate of discharge. Here in this problem what is given is the data what is given is this. There is a pipe of two different diameters. One is of 20 centimeter and the other end of the pipe is of 10 centimeter. So I can choose any one as section 1 and any one as section 2. Let me take the section 1 at the diameter 20 centimeter and the velocity as it is given at the 20 centimeter diameter is 4 meter per second, and also it is given the diameter at the other end is 10 centimeter. So here in the data what he has given is d1 is given 20 centimeter, so it is going to be as 0.2 meter. So because it is a cross sectional area, so it becomes a1, right? So here d1 is 0.2, so area is going to be pi by 4 d1 square, so it turns out to be 0.0314 meter square. And even in the same data he has given the velocity in the cross section 1 is 4 meter per second and d2 is 0.1 meter. So a2 is again d2 I know, so I can calculate what is a2. So pi by 4 d2 square, so it is going to be 0.00785 meter square. So what is asked in the problem is to determine the velocity head at section 1 and section 2. So what is velocity head? What is velocity head? It is given at the yesterday's last part of it, right? So velocity head is nothing but v2 square by 2g. So v2 square by 2g, if it is applied in the section 1, so it becomes v1 square by 2g, and if it is applied in the section 2, it is going to be v2 square by 2g. Okay, so what is to be found? I have to find out v1 square by 2g, as well as I have to find out v2 square by 2g, and also to determine the rate of discharge. What is the rate of discharge? Is nothing but q. Okay, so here because the velocity at the section 1 is given, I can easily calculate. So v1 is given, so I can calculate what is velocity head. So velocity head at the section 1 is v1 square by 2g. So that is 4 into 4 divided by 2 into 9.81. So it is going to be 0.815 meter. Okay, so the second thing that I want to calculate is velocity head at the section 2, that is v2 square by 2g. But there is one problem, means one restriction that I have is I don't know the value of v2, right? So to find out the value of v2, I must make use of the continuity equation, right? What is continuity equation? That is nothing but that is a1 v1 is equal to a2 v2, right? If you apply the continuity equation at this sections 1 and 2, it becomes a1 v1 is equal to a2 v2. Because I know the velocity, I know if I want to know the velocity v2, so equate it to v2, then it becomes a1 v1 by a2. So substitute the value of uh, a1 v1 and a2 in the equation. It becomes 0.0314 into 4 divided by 0.00785. Okay, so if you calculate, the velocity at the section 2 is 16.16 meter per second, but I want to know what is the velocity head. So velocity head at section 2 is nothing but v2 square by 2g. So it becomes 16 square, that is 16 into 16 divided by 2g. So velocity head at the section 2, that is v2 square by 2g, is equal to 13.07 meter. So here I have calculated velocity head at the section 1 is 0.815 meter, and even I have calculated velocity head at the section 2 is 13.07 meter. Now he has also asked you to calculate the rate of discharge. So I know what is discharge, right? What is discharge? Q is equal to A1 V1. Okay, even that can also be equal to A2 V2. Okay, any one I will make use to calculate the discharge. So here I have made use of A1 V1. So what is A1? 0.0314 into velocity at section 1 is 4. So if you substitute, it is going to be 0.1256 meter cube per second. So the unit of discharge is meter cube per second. But even a meter cube per second can be converted into liter per second by dividing it by 1000. Okay, because 1 meter cube is equal to 1000 liters. So the discharge is going to be 125.6 liter per second. Okay, so we shall solve one more problem of the same concept, right? Here the water is flowing through a tapering pipe having diameter 300 mm and 150 mm at the section 1 and 2 respectively. So here he has given at the section 1 the diameter is 300 mm, and at the section 2 the diameter is 150 mm. Okay, the discharge through the pipe is 40 liter per second. So the discharge, that is Q, is given as 40 liter per second. Okay, the section 1 is 10 mm above the datum. Okay, so he has given the datum part. Okay, that means the section 1 is 10 meter above, that is nothing but Z1 is given, right? And section 2 is 6 meter above the datum. So Z2 is also given as 6 meter. Okay, what is asked in the problem is to find the intensity of pressure at section 2, right? Pressure intensity is nothing but P2. Okay, he has asked you to calculate the pressure P2 if the pressure if that at the section 1, that is nothing but P1 is given as 400 kilonewton per meter square. Okay, so this is what I'll expect in this particular problem. Okay, here it is also a tapered pipe. Okay, this is also a tapered pipe. Okay, and he has given diameter at the section 1 is 300 mm. So this is D1 and this is P1 is given, right? Pressure intensity at section 1 is 400 kilonewton per meter square, and he has given this height, right? He has given this height. This height is nothing but Z1, right? Here at the section 1, so it becomes Z1. Okay, and he has given D2 and he has given the height from the datum at the section 2 is 6. So Z2 is going to be 6 meter. So he is asking to calculate pressure intensity at section 2. Okay, so here so D1 is given, it is going to be 0.3 meter, area A1 is equal to, so once I know the diameter, it is routine that I should calculate what is area at that section. So I know what is 0.3 meter D1, so area A1 is equal to pi by 4 D1 square, it is 0.3 square, so it is going to be 0.0707 meter square, and he has also given the P1, right? It is 400 kilonewton per meter square. Okay, now he has also given the height of the upper end above the datum is Z1 is nothing but 10 meter. Okay, so now he has given some data given to the section 2, right? So here in the section 2, what he has given the diameter D2, right? So he has given the diameter D2 is 150 So it is going to be 0.15 meter. So area is nothing but pi by 4 d2 square, that is 0.15 meter square. So A2 is equal to 0.01767 meter square. He has also given this height, right? So that is Z2, right? It is 6 meter, right? Now he has also given the rate of flow, that is also rate of flow or discharge, both are same, right? So it is Q is equal to 40 liter per second, but liter per second is not the SI unit, so you have to divide it by 1000, so it becomes 0.04 meter cube per second, because 1 liter per second is equal to 0.001 meter cube per second. Okay, so again I will make use of continuity equation and I will find out what is V1 and V2, right? Why I want to find out V1 and V2? Because to apply the Bernoulli's equation I must know what is V1 and V2, so that the unknown value P2 can be calculated. So to find out V1 and V2, okay, so I will make use of the continuity equation. So V1 is equal to Q by A1, right? V1 is equal to Q by A1. Actually Q is equal to A1 V1, but I want to know what is V1. So in that case it is going to be Q by A1. So Q is 0.04 divided by 0.0707. So V1 is 0.566 meter per second. Even V2 is going to be Q by A2. So if you substitute the value, it is going to be 2.264 meter per second. Now I will make use of Bernoulli's equation and I will apply for the section 1 and 2. How do you apply the Bernoulli's equation in terms of section 1 and 2 is nothing but P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Okay. Again I have written the equation, and here the motto of the problem is to find out the pressure intensity P2, right? Here I want to know what is P2. So I'll just reshuffle the terms. So I'll keep this P2 by rho g on the right hand side, and I'll keep the left hand part same. I'll send this V2 square by 2g and Z2 on the left hand side. If I send like that, it is going to be P2 by rho g is equal to P1 by rho g, it is as usual, but here it is V1 square by V1 square minus V2 square by 2g plus Z1 minus Z2. Okay, so here P1 by rho g. So P1 is, it is given as 400 kilo Newton. Kilo means again you have to substitute 1000, right? So 400 kilo Newton per meter square divided by 2g rho g. Rho g is nothing but uh, rho, here the water is flowing, so density is going to be 1000 and G is 9.81. Okay, now V1 and V2 both the values I know, I will substitute, and Z1 and Z2 both the values I know, right? In that case, if I calculate, so P2 by rho G is nothing but 44.524 meter. Okay, so P2 by rho G, right? The value that I have calculated is not the pressure intensity, it is the pressure head. It is not the pressure intensity, because the unit what I have written is meter, right? So if you divide the pressure by rho g, it becomes what? It is the pressure head. So to calculate the pressure intensity at section 2, right? So what I'll do, I just equate it to P2. Now I know P2 by rho g is 44.525. So P2 can be equal to 44.525 into rho g. Okay, in that case 44.525 into rho is water. For the water it is 1000 into 9.81. So P2 is nothing but 436.8 kilonewton per meter square. Okay, the essence of the problem is, okay, right, how to make use of Bernoulli's equation, and also here most of the calculations involved in the Bernoulli's equation to find out the velocity is going to be done by continuity equation, right? So you can see here, right, continuity equation plays a vital role to find out the velocities, right? Even in the previous problem you might have observed. Okay, continuity equation is a integral part to to find out the velocity, so that you can apply in the Bernoulli's equation. So the importance of continuity equation is going to be more in the Bernoulli's equation to find out the velocities. Okay, this is about the second problem. Okay, the next problem. Here in third problem, the water is flowing through a pipe having diameter 300 mm and 200 mm at the bottom and upper end respectively. So bottom end is 300 mm and upper end is 200 mm. Okay. The intensity of pressure at the bottom end is, so pressure intensity, what is pressure intensity, is nothing but P, right? It is not P by rho g. P by rho g is pressure head. Okay, so he has given the pressure, right? So it is nothing but 24.525 Newton per centimeter square, and upper end is 9.81 Newton per centimeter square. Okay, right? Determine, what is to be determined? Determine the difference in datum head if the rate of flow through the pipe is 40 liter per second. Right. So what is asking you to calculate is difference of datum head, that is nothing but Z1 minus Z2. Right. So he is asking you to calculate the difference of datum, right? That is nothing but Z1 minus Z2, and he has also given the discharge, that is Q, that is 40 liter per second. Okay, so I'll write down the data part. So diameter is 0.3 meter. So P1 is given 24.525 Newton per centimeter square. So here centimeter square is converted into Newton per meter square by multiplying it by 10 raised to 4. And same procedure is done for the section 2, right? And this is the schematic diagram of the problem. Okay, so this is at the section 1, which is at the bottom of diameter 300 mm and pressure is 24.525 Newton per centimeter square, whereas upper end is diameter is 200 mm and pressure is 9.81 Newton per centimeter square. So what is asking is the difference of the datum head. So here the rate of discharge or rate of flow is given as 40 liter per second. Again you have to convert in meter cube per second by dividing by 1000. So it is 0.04 meter cube per second. Again I will make use of continuity equation. So actually continuity equation is nothing but discharge Q is equal to A1 V1 is equal to A2 V2, but again discharge is given, so it is 0.04. That is why to find out V1, okay, it is nothing but actually Q by A1, so Q is 0.04. So 0.04 divided by A1. A1 is what you have calculated is so if you substitute, it is going to be V1 is 0.5658 meter per second, and similarly V2 is going to be 1.274 meter per second. Okay, again the procedure is almost same. Again you should make use of Bernoulli's equation. So again so for uh, section 1 and 2, so it will become P1 by rho g plus V1 square by 2g plus Z1 is equal to V2 square by 2g plus V2 square by 2g plus Z2. Okay, so here I wanted to find out what is Z2 difference of data mat. So I'll make this Z terms on one side, and I'll keep all other terms on the other side of it. So if I do like that, okay, right? So here Z2 is on the right hand side. I'll bring Z1 on the to the right hand side, and I'll send this V2 by V2 square by 2g and P2 by rho g on left hand side. So if I send, it becomes P1 by rho g minus P2 by rho g plus V2 square by 2g minus V2 square by 2g. So if you substitute all these values, okay, so the difference of Z2 minus Z1 is going to be 13.697 meter. So the difference of datum head here for the particular problem is Z2 minus Z1 is going to be 13.7 meters. Okay. So we shall take one more problem here. Water is flowing through a taper pipe of length 100 meters. So the length of the pipe is given, right? It is something different. Okay. The length of the pipe is 100 meter having diameter 600 mm and 300 mm at the upper end and lower end respectively. So upper end is 300 mm, lower end is upper end is 600 mm, lower end is 300 mm respectively. At the rate of the flow of discharge is the flow rate is given 50 liter per second. So Q is given as 50 liter per second. The pipe is having a slope of 1 in 3. So this is very important data. So it is going to be 1 in 3 means it is 1 by 30, right? So it is 1 in 30 means it is 1 by 30, right? Find the pressure at the lower end if the pressure at the higher end is 19.62 Newton per centimeter square is given. Okay, so let us write down the data he has given. So what I can say is the length of the pipe is 100 mm. Okay, so the dia at the upper end, so d1 is 600 mm, so it becomes 0.6 meter. So it is routine. Once I know d1, I should calculate what is a1. So a1 is pi by 4 d1 square. So if you substitute 0.6 square, it is going to be 0.2827 meter square. So p1, right? So he has given pressure at the upper end is 19.62 Newton per centimeter square. So again, to convert Newton per centimeter square, you multiply it by 10 raised to 4. Okay, it becomes 19.62 into 10 raised to 4 Newton per meter square. Okay, now at the section 2, the diameter is 300 mm. So it becomes d2 is equal to 0.3 meter. So a2 is equal to pi by 4 0.3 square. So it is going to be 0.0706 meter square. Okay, right? The flow rate is given, that is Q is equal to 50 liter per second. Again you divide it by 1000. So it is going to be 0.05 meter cube per second. Okay, this is about the data he has given. But the typical data what he has given is the slope, right? The slope of the inclination is given, right? The slope of the inclination is 1 by 30 and the length of the pipe is given, right? The length of the pipe is given. Okay, so the slope of the pipe is 1 in 30. So what is slope? Slope is nothing but vertical by the that is nothing but the slope is given as 1 by 30 and the length of the pipe is 100 mm, right? So I know the slope is nothing but tan theta, right? So the tan theta for this particular triangle is going to be uh, opposite by the length of the pipe, that is this one, right? So right, so this is going to be the vertical height into the length of the pipe, right? This is going to be the length of the pipe. So if you do like that, it is going to be what? One more the feature you should also consider is you should take the axis of the pipe on the datum line, okay, so that at least you can avoid the Z2, right? If you take somewhere above, again you have to calculate Z2 to avoid one unknown. Okay, I will make sure the axis of the pipe is going to be one end of the pipe is going to be on the datum line, so that you can avoid the one either Z1 or Z2 because it is bent upwards. Okay, so I'll take at the section 2, right? So at the section 2, because it is taken at the datum line, so Z2 is going to be 0. Only have to find out Z1, right? How do you find out Z1? Here you can calculate. As slope is 1 in 30. Okay, it is Z1 is equal to 1 by 30 into the length, right? So it is 1 by 30 into the length of the pipe. That will become 10 by 3 is equal to 3.3 meters. Okay, right? So it is going to be 3.3 meter. So therefore you can say the difference of datum head, now it is going to be Z1 minus Z2 is equal to 3.3 meter. Again it is a routine practice. Okay, so because he has given the discharge as 0.05 and I know what is A1 and A2, I can find out what is the V1 and V2. In that case, to find out V1, it is Q by A1. Q is 0.05. A1 value I know, right? So if you substitute, it is 0.2827. So it is going to be V1 is 0.1768 meter per second. Similarly, V2 is equal to Q by A2. So it is 0.05 divided by A2. So it is going to be 0.07 0.7074 meter per second. Now again you have to apply the Bernoulli's equation for the limits 1 and 2. So in that case it is going to be P1 by rho g plus V1 square by 2g plus Z1 will be equal to P2 by rho g plus V2 square by 2g plus Z2. Okay, so here the motto of the problem is to find out the pressure head at the section 2. So I will equate it to pressure head, that is P2 by rho g. In that case, I'll keep this P2 by rho g on one side and I'll keep sending all other terms onto the other end of the equation. So it is going to be P1 by rho g plus V1 square minus V2 square by 2g plus Z1 minus Z2. Okay, so I'll substitute the value of P1, that is 19.62 into 10 raised to 4 divided by 2g, rho is 1000 and 9.81 plus V1 is there and V2 is there and this is Z1 minus Z2 is 3.3. So if you calculate, okay, so this term is going to be P2 by rho g. Pressure head at the section 2 is 23.3046 meters. Okay, but here pressure head is calculated, but pressure intensity at section 2, that we have already done how to calculate this. So just multiply pressure head by rho g, right? It becomes 23.3046 into rho g, right? So rho is 1000 for water and 9.81. So pressure at section 2 is 22 228,573 Newton per meter square, or else you can say 22.85 Newton per centimeter square. Okay, the most important data that you should remember for this particular problem is the slope. Okay, if he mentions, okay, if he gives like what he has given in this particular problem, if he gives slope 1 in 30, even he can say 2 by 5, 3 by 7, slope may be any value. Okay, but he should mention what is the length of it. Okay, just multiply the slope with the length. Okay, you will come to know what is the datum head. Okay, while taking this the values, one should remember the axis of the pipe should the lower end of the pipe should be on the datum line. It is very simple. Okay, if you take the lower end of the pipe on the datum head, okay, right, so you can easily calculate this kind of problems. Okay, this is about this particular problem is concerned. Okay, we shall take one more problem. Here a pipeline carrying oil. Okay, here the fluid that is flowing in the pipe is a oil of some specific gravity 0.8, changing in diameter from 300 mm at position 1 to 600 mm diameter at say position 2. Okay, so it has okay, so here The diameter at section 1 is 300 mm. The diameter at the section 2 is 600 mm, which is 5 meter at a uh, higher level. So it means section 2 is 5 meter higher than the section 1. Okay, so it is indirectly given Z2 minus Z1 is equal to 5 meter. If the pressure at the position 1 and 2, right? So P1 and P2 both are given. So P1 is 100 kilonewton per meter square and P2 is 60 kilonewton per meter square respectively. Find, and also he has given the discharge. Okay, so he has given the discharge, that is Q is equal to 300 liter per second. What is to be found here is to find out the loss of head and also uh, the direction of the flow, right? So here when he mentions to calculate the loss of head, okay, when he asks you to calculate the loss of head, there is a slight change in the formula, right, in the Bernoulli's equation. That is P1 by rho g, the same formula I have got for Bernoulli's, that is P1 by rho g plus V2 square V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2, but there will be a loss of head, right, due to so many reasons. There will be loss of head due to so many reasons, because in the derivation of the Bernoulli's, okay, equation, okay, we assume the flow is ideal, okay, and the flow is going to be non-viscous, means if the but the fluid is going to be always viscous, that is where we the real flow will have some losses. Okay, so to be put very simple way, okay, right, so when you come across real fluid, okay, there will be some losses due to viscosity. That losses you have to add in the Bernoulli's equation as shown in this particular formula. Okay, so here I just applied that concept into this problem. Okay, so the data I'll just write down here. The discharge, right, Q is given, it is 300 liter per second. You convert into meter cube per second by dividing it by 1000, so it becomes 0.3 meter cube per second. Specific gravity of the oil is 0.8, and what is density? Just multiply the specific gravity by 1000, so that the specific gravity is going to be converted into density. So 0.8 into 1000, it is 800 kg per meter cube. Okay, now let me write down the data at the section 1. So diameter at the section 1 is 300 mm. So here it is given 300 mm. Okay, so it is 0.3 meter, and similarly we know this, once I know diameter, calculate area, it is pi by 4 d1 square, it is pi by 4.3 square, it is 0.0707 meter square it comes out to be. Now he has also given the pressure at section 1, right, P1 is given 100 kilonewton per meter square, and here the velocity. Okay, and one more thing he has given in this particular problem is Z2 given, right? He has given Z2. How here he has given Z2, but he has not given Z1. So you can say, you can make Z1, okay, 0 by taking Z1 on the datum, right? So if you take the section 1 at the datum line, so Z1 becomes 0. So same thing I have done. So if the datum line passes through the section 1, then Z1 will be equal to 0. Okay, so I can calculate even velocity V1, right? So velocity at section 1 will be equal to Q by A1 from the continuity equation. So it becomes 0.3 divided by 0.0707. So it is going to be V1. So V1 is 4.24 meter per second. Even at section 2, the diameter D2 is given as 600 mm. So it becomes 0.6 meter. So area A2 will be pi by 4 d2 square, it is pi by 4 into 0.6 square, so it is 0.2828 meter square. Okay, and he has also given P2, pressure intensity at section 2 is 60 kilonewton per meter square. Okay, now so here section 2 is 5 meter above the datum. For that reason Z2 will become 5 meter, and similarly I can calculate V2 by using continuity equation. So Q by A2 so is equal to 0.3 divided by 0.2828, so V2 is equal to 1.06 meter per second. Okay, so first task of the problem is to determine the loss of head. Okay, let me write down the Bernoulli's equation for the losses. Okay, then it becomes P1 by rho g plus V1 square by 2g plus Z1 will be equal to P2 by rho g plus V2 square by 2g plus Z2 plus HL. This is integral part. If you add HL, so it becomes the Bernoulli's equation for real fluid. Okay. Now the problem is to find out the solution of the problem is to find out the HL. So send all the terms on left hand side, keeping HL on the right hand side. So it becomes P1 by rho g minus P2 by rho g plus V1 square by 2g minus V2 square by 2g plus Z1 minus Z2 is equal to HL. Okay, so because denominators are same, I'll just substitute. It becomes P1 minus P2 by rho g plus V1 square minus V2 square by 2g plus Z1 minus Z2 is equal to HL. Okay, then I can put all the values into this equation. So HL loss of head is equal to P1 is given 100 kilonewton per meter square. So 100 into why it is 1000, because it is kilo. Kilo is 1000. So 100 into 1000 minus 60. It is also given 60 kilonewton per meter square. So it is 60 into 1000 divided by rho. Rho is nothing but here the fluid density is 800. So it is 800 into 9.81 plus 4.24 minus 1.06 square divided by 2 into 9.81. Okay, plus it is Z1 minus Z2. So Z1 is 0, Z2 is minus 5. Okay, so if you substitute all those values, okay, right, so loss of head is going to be 0.9 meter. Okay, now he has also asked you to mention, okay, right, the direction of the flow, right, because I have got this loss of head is positive. Okay, means the references that I have taken is correct, right, means it is taken, it is flowing from section 1 to section 2, right. You, in case if you have got this loss of head negative, okay, right, it doesn't mean that loss of head is going to be negative, means the references that I have taken is wrong. Okay, because here it is given that the flow is taking from the section 1 to 2 and the loss of head is positive. Okay, right, so the flow is taking place from section 1 to section 2, right. Keeping all these basics into mind, I can solve any kind of problem, right. So here one should remember during the problem, okay, the continuity equation is used to calculate the velocity, so that you can make use of these velocity terms into Bernoulli's equation. This is first thing you should remember. Whenever he gives the slope, right, that he had already given in this maybe the fourth problem. Okay, if he gives the slope, okay, right, then you have to make sure the lowest end should be taken on the datum, so that you can make right, you can make one datum height as 0, so that the other datum can be taken as the value, right. And one more thing here is uh, if If loss of head is been asked to calculate, then you have to make use of Bernoulli's equation applied for real fluid, that is this, right? You just have to add the loss of head, okay, at the end of the formula, right? It is all same. If you, this is the extra term you get in the formula, right? This completes the problems associated in the Bernoulli's calculation. Thank you for joining in.